I'm Anil Kumar. Welcome to my series on rational functions. We'll try to sketch graph of a rational function. The function is given to us as x square over x square minus 1, right? So as you know, I make always rough sketches. So we are going to do it right here. Now, rational function graphs, a couple of things are very important to understand. One is asymptotes, right? So if you're given this, we have horizontal asymptote in this case. So what is the value of horizontal asymptote? Well, the leading coefficients are 1, degrees are same, so we get y equals to 1 as our horizontal asymptote, right? Correct? How did we get this result? Key is when degree of numerator and denominator is same. In that case, we have horizontal asymptote, which is ratio of leading coefficients. Correct? So 1 and 1, correct? So we get y equals to 1 as our horizontal asymptote, correct? So at 1, I'm drawing this line here. So that is our horizontal asymptote. We'll write this point here as 1. When I say horizontal asymptote, that means the function is going to approach this as x approaches negative infinity and approach that when x approaches positive infinity. Let's look into the behavior. Now, if I have a large value here, both are positive, right? Square will make them positive. That means in both the cases, we are approaching from top, correct? So that is how we are approaching. So that's very important. That's the behavior near the asymptote, right? So this which I'm showing here is behavior at asymptotes. Is that clear to you? Now, second important thing which we have to look into is what? Is vertical asymptote, correct? Do we have vertical asymptotes? Yes, we do. We could write this function as x square over x plus 1 times x minus 1. So it is 0 for two values. So the vertical asymptote is at x equals to plus and minus 1. So those are the vertical asymptotes. So let me sketch the vertical asymptotes now. Let's say these are our vertical asymptotes, correct? See how easy it is to sketch rational functions, right? So these are the values at minus 1 and plus 1. Perfect. Okay. Now, we need to check the behavior near the asymptote. The vertical asymptote this time. Now, if I have a value which is greater than 1, for example, if I have a value greater than 1, then this value is positive, right? So that is to say, when x is approaching 1 from the right side, that means from this side, right? Then this is positive, then y value is positive infinity. So your graph will go kind of like this. And when x is approaching 1 minus 1, let's say from the left side, so we have a negative value here, even then they make it positive, right? So it is approaching on this side. However, if I have x value which is less than 1, right? Less than 1, that is to say approaching 1 from the left side or approaching minus 1 from the right side, right? In that case, the y value approaches negative infinity. Correct? So that is the behavior near the curve, right? So that means that the graph on this side will be approaching negative infinity. You understand this part, right? So if x is between plus and minus 1, it is going to approach this place, right? And at 0, we get our asymptote, right? So the third point will take value at 0. So what is the value of the function at 0? If I substitute 0 here, I get this as equal to 0. So that is also a point on the function. Perfect. Now from the behavior itself, we could actually sketch our graph, right? So this is enough to sketch the graph. We have a curve which is kind of like this here and is symmetric, right? We'll write more characteristics later, but let me first sketch and then describe you the characteristics. I think that would be better, right? Now those are asymptotes, okay? So that's how we are going to get it. You will also realize that f of minus x is equal to, if I do that, is equals to f of x. That means it is even function. So even function means symmetric about y-axis. Is that clear? So that's the y-axis. You can see it is symmetric about y-axis, right? Now to get some points here, which is very critical, what should you do? Well, just plug in, right? Plug in half here and calculate. So to get these points, what you should do is you plug in half, right? Get the value. You plug in minus half, get the value. You plug in f 1.5, get the value. Plug in f minus 1.5, get the value. So those things I'm leaving for you, correct? So once you go plug in these values, use your calculator, you'll get these points, which are good enough to sketch your graph. Perfect. So what we are focusing on are these 5 things. Horizontal asymptote, right? Vertical asymptotes, 2 in number. X-intercept, and that is also the y-intercept at 0. Behavior near the asymptotes, which I've tried to explain you here. So those are 5 critical points, plus get some values for accuracy. Since I don't have a graph paper here, I'm not really calculating them, right? So just plug it in your calculator, find the value, write down these points. So you have a perfect graph for this given rational function. I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.